In this video, we will be starting the new series of the Beginner's Guide to SDL2 in the Go language. So this is the first video in this series. You will want to go to github.com, Programming Rainbow, Beginner's Guide to SDL2 in Go, and you will want to clone that repository. You could just take the address straight from the browser. And then in the terminal, if you don't already have these installed, you will need Go installed in your system. You'll also need SDL2 with the SDL2 add-on packages for image, TTF, and mixer. So that'll be SDL2 and then SDL2 image, SDL2 TTF, and SDL2 mixer. Okay, so on an Arch-based system, it looks something like this. And I already have these installed. And if you're on say a Debian or some of the other systems, I believe they do separate the packages for SDL2, the actual libraries, and the header files. So you'll need both of those. You'll need the header files. But on the Arch-based systems, they're in one package. On Windows, you'll need to do whatever you need to do to get those up and running. I have no idea what you need to do. So you will need those installed. But so we're gonna clone this repository. Let's make sure I am in the top level. I can't remember if I have it cloned already or not, so we'll do that. Okay, so this is what the folders that we cloned looks like. We have fonts, we have images, we have music, and we have sound. These are assets that we're going to be using in this project. And then the code for all of the videos that I'm going to create, there's going to be 9 of them, thereabouts, is already set up. So you can go through and look at any of the code. You know, each one of them has a main.go in there. And if you want to use any of them, just copy them into the top level directory where you see go.main here, and then you can use it. So they're not meant to be used in the directory they're in. They're just in there for you to grab whichever one you want to use. Okay, so I kind of want to show how to set up Go, because I already have it set up with this this Go mod, Go sum, and all this. So let's just show how to set that up real quick. I'm going to delete these files. These are not files that you edit directly. Go sets them up for you, so I'm just going to show how to do that. So I'm just going to delete them. Just in case you were making your own project and you had a clean directory and you just wanted to make your own project, this is what you would do. Let me make it a little bigger. So you would do, so I want to make the project that is going to be the Beginner's Guide to SDL2 in Golang. So I'm going to give it the exact same name as the folder I'm inside of. So what I would do is I'd say go mod and then init, and then I'm going to give it the title of the what I want to call this module. Okay, and that is going to create that go mod file. Now again, we don't edit that directly, but this is what it created. It's basically got the version of Go I'm using, and it's got the name of the module, the name that I want for this module. So the other thing is when we add in packages that we want to use, so in here, I'm using some packages and it says I could not import them, okay? So that's fine. We basically need to run go mod tidy, and it's going to actually pull in these. It's going to create another file for us, and it's going to change this file. So if we look into it real quick, we only have 2 lines in here, right? But this would be all good except for these right here. This is basically, these are part of the standard library of Go that I'm using. And then down here, these are third party. So whenever you add one of these in, the third party one that hasn't seen before, you're going to want to do this command here, which is go mod tidy. And that's going to take care of those for us. And so those are now in the system. And now we do have another file over here. And again, we don't edit these. The Go does this for us. We have this one here. And if we look at the Go mod again, it's actually changed. It says now require. And this is, we're going to look at this website in a minute here, but I'm just showing you, if you're making your own Go project and you're using a third party, initially you're just going to want to use go mod init to set it up and the name of the module you want to give to your project. And then if you need any third party that are not part of the standard library, you just require them in your Go code, and then you can run go mod tidy, and that will, if you require them in here, this is from GitHub, you'd use go mod tidy, and that would actually set everything up for you again. So I just want to show you the final project, what it's going to look like, and then we are going to start from the beginning. So this is the file that when you clone this from the repository, there's a code in each one of these. The video 9 file is the final one, and that is that's a duplicate of what's in the top level directory. So that's what we're going to run right now. So we can do this a couple ways. We can say go, and we can say build, and our only file that we're using is main.go. So we can do this right here, and this will create a binary for us. And if I run this binary, I can just say .main, because the binary was created right here. So I can do this, and it's going to show the project, and you're going to see that I have text that is moving around the screen that says SDL. I have an image on the background that is the SDL image. I have the little gopher, the Go gopher, that I can control with the AWSD keys or the arrow keys. If I press spacebar, it's going to change the background color that's behind the image. We also have a title. We have an icon loaded. And it'll also, every time the SDL bounces off the wall, it says SDL. And every time I press spacebar, it says go. So that's what this project's going to show you. And it does play music, but I'm going to mute the music right away so that I can talk over it. So let's just, now I can play it this way, and I'll show you later how the other way to do this. So there's the SDL moving around on the screen, and I muted the music.
SDL.
Now if I press spacebar, I can change the background color.
SDL. SDL.
And it says go, and I can move the little gopher around with the, with the arrow keys or with the AWSD keys.
SDL.
And it's got a title up here. It says music for this one, and it has an icon that I'll show you at a later time what that icon looks like. I'm not using a window manager that shows an icon right now, but it is there. I do show you how to do that. So we don't have to build it with go build and all this. We can actually just say go run main.go. And this will compile it, but it compiles it in like a hidden directory and then just runs it for us. And that will do the same thing. Okay? I just wanted to show that. That's what we'll be using. We'll be using the go run. Okay, so I actually want to start from the beginning. So we're going to delete this initial file right here, this main.go. I'm just going to delete this and then recreate it. And we can delete these too. It doesn't really matter. I'm going to leave them because they're actually not going to change for the rest of the project, but I did show you how that they are made earlier. So I'm just going to call this main.go. And now we have a blank file. That's fine. And let's just talk about what it is we're doing here. So this is we're using the SDL2 implementation for Go, the wrapper. I'm not thinking of the right word right now, but and it's right here. It's at GitHub, and it's Deco. I'm not sure the name here, but if you can see it here, and it's Go Tac SDL2. Okay, so this gives us our implementation, our bindings or wrapper for SDL2, so that we can use it with the Go language. Now, there is one thing that you have to keep in mind here. Go is a really amazing language to use, and it has it's very simple. If you really like C language, and if you like Lua, it's like somebody took Lua and tried to make C in Lua or something like that. It's really easy, and it is garbage collected, which is good and bad depending on what you're doing. But since we are interfacing with SDL2, which is a C library, the garbage collection will not be happening for any of the SDL2 stuff. So you have to remember that. Go is garbage collected, but the SDL2 part of Go will not be garbage collected. We'll be dealing with that ourselves. Okay, so I'm just going to show you here the documentation. They have their own documentation, and then they have the original SDL2 documentation. So This is the SDL2 website. It's very white, I guess. And this is the documentation for the SDL2. That's what is the original Winky right here is being linked to. And if you just Google anything about SDL2 that you're looking for, you'll pretty much get a link to how it shows on this website. So this is pretty big. If you've seen my videos for C or C++, we're using this the whole time. But for this one, we're going to be using the Go documentation for it. So if we were to click on the Go documentation for Go SDL2, that would take us right to this page. And this is broken up into the modules. So we have image, mix, we have SDL2 and TTF. And for this video, we're going to be working in SDL2. If I open that, it's this page right here. So if we look at this one, this is describing all the kind of functions. And if you click on any of these, it'll go further down. I've actually opened each of them up in a page because this page gets quite long. And I know exactly what I'm looking for. So the things that we want to do in this video is we want to initialize SDL. We want to be able to close SDL. We want to create a window. We want to destroy the window. We want to create a render. We want to destroy the render. We want to clear the render. We want to present the render, and we want to delay the program. And that's everything that we're going to be doing in this, and doing all the boilerplate in C to make it happen. So I know exactly what I'm looking for here. So in here, if I were to type in, like init, not that one, that right here. I'm going to be looking for this function, but I already have them opened up. So init is just a function, and this is going to be, if we were in SDL2, this would be SDL underscore init, which is right here. But for this module, since it's going to be imported as SDL dot, it'll be SDL dot init with a capital I. And that's going to be how everything, all the SDL stuff, instead of capital SDL underscore and then the name of the function like it would be in C, it's going to be lowercase SDL dot and then the name of the function for Go. So it's just basically the same names most of the time. So this one is very simple. We have some flags, and I'm not going to explain the flags in this video. I'm just going to show you what flag we're using in this video, and then we'll discuss that in another video, because this video is going to be long. But this initializes it. We can pass a flag in, and we receive an error back. So we can check this error, and we're going to see what we can edit that error and then pass it on down. And then we have quit. So, and quit doesn't have any parameters and doesn't return anything, but it shuts SDL down. So anytime we do one thing in SDL, I want to do the other thing to clean it up, because we need to treat this like it's C, not like it's Go. Whatever we create or start, we close down or we remove or delete or destroy or whatever the equivalent is. Okay. I want to see the flag though. It's init. Okay, here's the flags. So it's further down. So I'm going to be using this flag down here, init everything. I'm not going to explain that much on these flags in this video because I will touch on them in a different video. Again, this video is too long. I'm just initializing everything. But you can initialize the audio system or the video system for this project. It's going to be everything. Okay, so I just want to show you that real quick. So let's start getting into code, because yeah, we need to start building something. The first thing we want to do is I'm going to run package main. The name of this is going to be the main. Okay, and then we'll go down to imports. And so I'm going to import the format. These are part of the standard library. So I'm going to import the FMT package and the OS package, and you'll see why in a minute. And then we're going to need to import that GitHub SDL2 that we saw there, the actual GitHub thing. We're going to use this actual GitHub right here, and we're going to import that. So I'm just going to use a block, an import block. So we can import this just with using parentheses to import an actual just block. So the standard library stuff is FMT. We need that, and we need OS. And then the third party is the GitHub one. And it isn't exactly like this. We want the package from this module. So this Go SDL2 is a module, and we want the package from it, which is SDL2. Okay, so that's the address and then SDL2. We will have multiple ones later on. That'll be image, TTF, and mix. But for this video, it's just SDL2. So that is our import block. That's all that we need to import for this one. I'm going to make a couple global constants for this, just to hold window width, window height, and the window title. You could put these as variables, but I'm okay with having them be constants. I don't have any global variables whatsoever, but a couple global constants just for the overall project, especially width and height, allows anything to get access to it. So I'm going to create a block of constants. And all of these are going to start with a lowercase, and I'm using Go's camel case style, but they're all going to be lowercase because I'm not exporting any of these. So it's going to be 800 for our width. And it's going to be 600 for the height. I think my formatter is going to end up lining these up anyway, but... And then I'm going to have a window title. And it's going to be... For this video, it's going to be open window, because that's what we're doing. So that will be that's our global constants. We are going to use a struct. So we're going to be using a little bit object oriented, you know. So we're going to have a type declaration here for the struct. And the only thing we're putting in here for this one is going to be our pointers for the window and the renderer. And again, this is SDL2. Even though this is the binding and Go, we need to manage these pointers for the window and the renderer. So even though Go is garbage collected, this part is not garbage collected. I'm just going to leave this. I'm kind of skipping ahead. I want to do this in sections. What I really want to get to is initializing SDL. That's the very first thing we need to do, is initialize SDL and shut SDL down before we deal with the game. So I'm going to make two functions, and these are not going to be methods or member functions for the Go struct, which in Go would be methods. These are just going to be just functions, just a function to get SDL up and running and all the modules that we need to get up and running, and then to close them all down. So I'm going to make the first function is going to be initialize SDL, and then a function called close SDL. So initialize SDL, and that's not going to take in any parameters. And then I'm going to make a function called close SDL. And they're not returning anything either. They're just doing something for me. So the very first thing that we saw here, this initialize, this one right here, this function initialize SDL with the flags. So we already know the flag that I'm going to pass in. But this function, when we call it, we pass in the flag, and then we're going to capture this error. Okay, so this is going to be, I'm going to walk through it this time, but then every other time that we see this, I'm going to just, you know, we've already done it one time. So this first time, I'm going to show you the setup of this. It returns an error, but I actually want to add to the error. I want to modify the error that is coming out of this, and then I want to pass it on down. So we are running this. We are passing in this is the init everything. Yeah, this one right here. This SDL init everything, which I can just say init everything. It's part of the, you'll see it in a second. This is the parameter that I'm passing in here. Yeah, it's only here. I don't know why it's here, but anyway. So I'm going to be passing this into this function. So the way that I'm going to write this is I want to capture the error. So I'm going to have multiple things that keep capturing something called a variable called ERR that is of type error. So I'm just going to create that first because I'm going to use it multiple times. So I'm just declaring this error, ERR of type error, and then I'm going to add my the flag, I'm going to make a variable that holds this flag. That's because that you can add multiple flags together. They can be ORed, and I don't want to talk about it in this video, but you will see it later on why I'm doing this. It's because you can add multiple together, and we can just hold it in a variable and use it in the variable. So this is SDL flags, and these flags are of type uint32, so they're unsigned 32-bit ints. I do need to say it won't figure it out on its own. I did try using the colon equals, and it didn't automatically figure it out, so I have to specify it directly what it is. But this is the way we use it. It's the SDL, and it's init everything. Okay, and it's all capitalized. These are from the SDL2, the macros or the preprocessor constants, and they're always all capitalized when you see this. So I'm basically, now you could put multiple ones in by putting a single pipe, and this is called a bitwise OR operation. Not a logical OR, but a bitwise OR. And what it does is it adds, it doesn't add them. If any of the bits are turned on in either of them, it turns that bit on in the output one. So we'll talk about that in another video, but you can put multiple and we'll store it in a variable so we can use it. So the way that we're actually going to use this init function now for SDL is we want to capture the error coming out of it. So if we looked at it's returning an error, and we want to capture that. So it's going to be if and this is SDL init, and it's a capital I. Almost all the SDL functions or methods, you might call it a method here, but the functions for SDL are going to start with a capital letter, the way that they're titled, and they're going to be camel case, but starting with a capital letter. So you're going to have the SDL because that's the module we're working with, but then it's dot and a capital letter. And if we were in C, it would look like this. This is what the function looks like in C. So everything in Go is similar. So we want to pass in our variable. SDL flags. And then what we want to do is we want to compare this error to make sure it's not null. So this error it's an interface type. So we can't just test it directly. We have to see if it's not null. But I also need I need it held in a variable because we're gonna be returning it later. So I do want to capture it here, but we do need to check this equality for the if statement. So it's going to be is not null, or nil, sorry. Okay, so basically we're running this function and we're capturing the error. Now, if no error happened, this will be nil. But if an error did happen, if something went wrong, this is going to be populated with that interface, whatever the error was, which is going to have a string in it, and we want to manipulate that string. So this is seeing if it's not nothing. If it's not nothing, something went wrong, and we got to deal with that going wrong here. But if it is nothing, we don't care. We just want to keep going. So this is if it's not nothing. We only care if it's not nil. If it is nil, everything went good. But if it's not nil, something bad happened. Okay, but we want to return from this, and we also want to return the error. So we could just do this. We could return error. And up here in the close, sorry, this is supposed to be, this code is supposed to be an initialize, not close. Sorry about that. I'm just going to move it. What needs to be here is SDL.quit. And there's nothing being returned from here. But up here, there is a return. There's an error is being returned from here. So if we put our code in here, where it should have been initially, sorry about that. If we put it in here, we do need to return from here. And since we've already created error up here, we can return error. Okay. So when we created this variable error, it is nil. It's already nil in its default state because this is Go, and everything's initialized to 0 or nil. So this is nil. So if it all goes through here and this still return nil, it's still nil, and we return nil, that's fine. But if an error occurred, we're going to return the error that occurred, right? But I don't want to just return the error. What this will return is the actual, if you've used SDL in C++ or any other language or C, we're going to be using a function to get the error out, which is SDL get error. Okay, this would return the actual error that occurred. And that's what this is returning. This error right here, from here, is returning this error, which is fine. But we want to add on to it our own message and then put those two together. So that's why we're using the FMT package. So if we say FMT, now this isn't a normal string thing. We're changing an error message. So this is dot error f. And what this is going to allow us to do is put together a new string with our old error message string into a new error and return that. So I want to say error initializing SDL2. Okay, and then I'm going to put a colon and a space, and then I'm going to put %v. Okay, this is going to allow me to put error here. Whatever error is, it's going to be here. This v is just a generic one. It allows it to basically turn anything into a string if it needs to. So it's going to be this text. If this goes wrong, I'm going to see this text happen with a colon and a space, and then whatever this was will be here for the rest of the string. And then that whole thing is going to be wrapped up as our error and returned. So it's just, we're just editing. We got this error, but we just want to add this string onto the beginning of it. So we're using the FMT package to reformat this error message, taking the error that exists and this string here and putting them together. Okay, and we're going to see this a lot. I'm going to be using this constantly. All of the SDL functions are going to be erroring like this. All of the, what we would normally check any of the errors, they're just going to all be returning an error, and we're going to be doing something similar to this on all of them. Okay, so this is the way that this initialize is going to look. So this brings SDL2 online. This sets it up. SDL2 is up and running. This shuts down SDL2. SDL2 is being shut down. We saw those two functions already. Okay. Now, I am going to be using this this game right here, and what we're going to be putting in there is we need to create a window. Okay. So in here, well, let me show you the window function. So we have these functions here. Where is it? I'm going to close these since we're done using them. This init function we've taken care of, and the quit function. We've done that. Let's make a main loop and make sure that they run first. So let's say func main. And I'm going to do the same thing in this one. I'm going to make this error. I'm going to declare this error right here because I'm going to use it multiple times. And what I want to do is I want to initialize SDL, but I want to close it down no matter what happens. So I'm going to defer closing it down right away, and then I'm going to try to initialize it and look to see if an error occurred. Okay, so let me just show you the looking to see if the error occurred. So we've already have this SDL initialize SDL up here, right, that we've created. So we need to call it from main. So I'm going to run an if on this because this could fail. You know, we could get an error back from this. So it's going to be the same thing, error. So that initialize SDL, and then we're going to check the error to see if it's not null. Sorry, nil. I keep saying null. I've been in C++ right before this, so I keep saying null on everything. And then we want to print the error that we got, but I do not want to print it to the standard out. I want to print it to standard error. So you have standard in, which is your keyboard. You have standard out, which is your terminal. And you have standard error, which also could be your terminal, but you could also redirect it somewhere else too. And that's where errors should go. Error messages should go to standard error, not standard out. Okay. We will still see them on on the terminal. If we create if an error message happens, we'll still see that, but we could redirect it somewhere else. So that is the normal way that you would deal with errors. So I'm going to send that error that we're receiving from SDL, initialize SDL, and I want to print it out, but I want to print it to standard error. So that is why we have OS. This OS module or package is imported. So the format we're going to use is again differently, and then the OS is going to allow us put it on standard error. So assuming that an error happened and this error variable is filled up, I'm going to use the format, and then this one's fprint, which is kind of like fprintf in C. And just like in C, if it was fprintf, the first thing we do is send it to what file that we're sending it to. It gives us the ability to decide where we're sending this. So it's OS, and then it's std error. That allows us to send it to standard error. And then we're going to use the same thing that we used before. The string that we want to send is actually just the error. So we're going to use the %v, and then I'm going to put a new line character with it and the error. Whatever the error is, which is basically this, it's going to be this message plus whatever the real error that was already here. That's going to be together as one long error message now. This is going to capture it, and this is going to print it out, but not to standard out, to standard error. Okay? So if that happens, we actually just want to return from this. We don't want to go any further. So we just want to return. We want to print it out and return, and this program's done now. But I actually want, so I don't know, I could have multiple things happening here in this function. There's going to be 4 or 5 different things that happen later on. Any one of these can error and return from it. So if I've loaded 3 or 4 things up and then it errors, I want to make sure that they're all unloaded. So I actually want to call close SDL2 no matter what. So I'm going to put it up here above it. I'm going to defer it. And this is going to, no matter what happens with this, if this goes clean or errors, this is going to get called. When main goes out of scope, close SDL2 is going to get called no matter what. So I'm not putting it after it because this could return. I could put it inside of it and then return, but then I would need to put it after it too if it didn't fail. So I'm actually just going to put it above. I could split it up too. I could call it, and then I could defer it, and then I could check the error after. I could do all these things, but I'm just going to put it directly above. I want close to get called no matter what. Okay? So that should allow us to initialize SDL and to shut down SDL. So let's just see if that works. Okay, make sure I haven't forgotten anything. I have this. I don't know if it's going to complain about this not being used. We could just comment it out for now. So I'm going to go run main.go, and we're not going to see anything. But I could put something. I could put a message in. I could put a message in where it's clean right here. Let's put something like that. Okay. I'm going to remove these, and we're going to keep moving on. But we know these functions are being called, so that's good. So what we need to do now is we need to open a window and then close the window. So let me save this. Let's look at the next function. So create window is how we create a window, and it's going to take a string. That's going to be a title. It's going to take an X position, a Y position, a width, a height, and it's going to take some flags. So I used centered pause. So let me show you so what's going to happen here is we've already created a constant for the string. We're going to use that. Now for X and Y, we want the window to be centered, but we don't know how big the origin of your, I have 1080p resolution right here, but I'm only using 800 by 600. So we would need to use some maths to actually find out with the width of our screen and the width of the window we're creating inside of it, where the X position needs to be for the left of the screen and where the Y needs to be. So SDL has actually got a built-in macro that does that for us, and it's called window pause centered. So I'll show it here. So right here, window pause centered. It's a macro that actually gets us the center. So we're going to be using this one right here, and we're going to use it for both X and for Y. So that's what will happen. And then for width and height, those are already constants that we created, so we're going to use that. For the flags, you don't have to use anything. We could put a 0 there, but I'm using one called window shown. So it makes sure the window is being shown. Maybe some window managers might open up the program and then the program is minimized or something. This one just makes it sure it's shown. So it's window shown. Yeah, this one right here. Window is visible. So I'm going to use this. You don't really have to use it. It doesn't really matter for this one. It's not really an important, it's going to work. The default's going to be just fine. But we're going to use this window shown. So I'm just kind of showing you what we're going to build. And that's going to populate a pointer for us. So this is a pointer that's heap allocated. It's a C pointer. Go is not taking care of this for us. It's going to return a pointer, which is of type window. And it's also going to return an error. So normally we would check to see if this window pointer is nil or null. But for this one, the error actually has that error return, the SDL get error already in it. So we're going to check that one instead. And that's how we're going to check everything. We're going to be checking the error. But in C and C++, we would check to see if this is null. But for Go, we're checking the error. But we are capturing this. And since we do capture this window, the pointer to the window that we're creating, we have to destroy it. This would be a function call that we passed in the window to it, but in Go, since it's more object-oriented, the destroy is actually a method of window. So we can tell the window to destroy itself. So it's just if we have our window object already created, we can just call the destroy method on it, and it returns an error, but we're not going to pay attention to that. Okay, so let's do that. And you're going to see some of the stuff that we've already set up. We're just going to be repeating it. Now, this method we made here, or this function we made here, this is all about starting up SDL stuff. So the SDL module itself, if we need to do the image module, the TIFF module, all that, that's what's happening here. And this close is shutting it down. It's got nothing to do with the game struct right here. This is just generic SDL stuff that's going to come online. So for this, we are actually going to be using the game struct. So on here, we need to put in because we need to hold on to this window pointer that we're going to use. So it's going to be called window, and it's of type SDL window. Okay? So we're going to be holding that in game. Now below the initialize, I'm going to start doing the methods of game. I'm just going to do them down here because game is declared up here on top. These two functions are first, and then after that, we're going to deal all the methods of game. So I want an init method for game that is going to initialize all the game stuff. So func, and this is a method for game. So it's going to be g pointer to game, and it's called init. And we also need to create this game. So I should have done that first. So up here above it, I don't want to initialize game when I create it. I want to separate them out. So I have a function that's just creating a new game. So I have a function that's just going to create the game object and set any basic variables, but any complicated things, I'm going to do it in the init. So this will be called new game. And this is just a function. This is not a method for game. It's returning a pointer to a heap allocated game. And this is managed by Go. So this is, heap allocated stuff in Go is garbage collected. And all this is going to do is make us an instance of game and return it. But it's also going to do any kind of setting up any initial variables that we need that are not set to 0 or nil. So this is just getting the address of a game instance and returning it. And there will be other stuff later. So that just gets us the instance of game. So now that we can use it. So down here we need to, in the main function, we need to get this instance of game. So there we go. That's we're calling the new game function, and it's going to get our G object. Okay. So now that we have that in it, we can initialize our game. This is going to be where anything complicated happens, loading pointers and stuff like that. So right away, I'm going to make the var error. And so for the window, we're going to do the same thing that we have been doing, where we capture the error, but this time we're also capturing the pointer that's coming out of this. So this returns a pointer and an error. Right here, we return the window pointer and the error. So it's going to be if, and the window pointer is G, because we've called our game, we've called it G in here. Window, and we're getting error 2. And this is SDL create window. Okay, so the first thing we needed was the title, and we already have that. That's a global constant, so we can get window title. That's our global constant that we've already defined. And then the next two is the X and the Y. And remember, we're using the window pause centered, and this is all capitalized. This is a macro in SDL. Window pause centered, and that's for both X and Y. Now you can actually put these at 0, or you can put them at undefined, or you can put your own number in. But I just want the window to be centered, so that's why I'm using this. And I'm going to break this line right here. Yeah, because I'm running out of room. So that was that. Now with the width and the height, there are also constants. So we can use the two constants that we created, which is window width, window height. And then we have our flag right here. And again, we can put this as 0, but I'm just going to put the SDL window shown. And again, this is a macro, so this is all capitalized. Window shown, yes. Okay, so that's the thing. But now we're the if statement. We're checking if error is not nil. So error not nil. Okay, so what we're doing with this is just like what we did before. This error message right up here, we're going to be using this kind of thing over and over again. So I'm just going to yank this. I'll put it down here. But we need to change this message. So we're going to say error creating window. I like having our own message here. So if anything goes wrong, we know exactly in the code because we've put descriptive messages, and then we'll see the actual error that occurred. So that error creating window, and then we can actually find out why that error occurred. There might be more information that could or could not be helpful to us. So since we've created a window, we need to destroy the window, and destroy is an actual method of window. Here, and if you scroll down that one page that has all the function, you'll see all the Windows methods will be together. So in C, this would be underscore destroy window, and we would have to pass in the window pointer to it. But in Go, because of the object-oriented nature of it, we have the window dot destroy, and that does the same thing. And where we're going to put this is in, we're going to make another method for a game that is close. So down here. And I messed up here. This is returning an error, right? And also right here, I need to return the error. Okay. So that the initializer function or the initializer method for game is returning an error. I am capturing an error here and returning it. If no error occurs, this will be nil, and I'll still be returning nil. That's fine. The close method does not. We're not returning error from this. We're just closing things, shutting things down. We're not shutting things down. We're reversing whatever we've done in initialize. So we have this pointer. This pointer does not get cleaned up by Go. We have to deal with this ourselves. So this would be, first I want to make sure that the game object actually exists, because I could call this and some error could have occurred where game never actually gets created. So first I'm going to just make sure that game exists. So I'm going to say if G is not nil, so if G is not nil, then I'm going to tell the window, G window, to destroy itself. And also, this destroy method does not set the window pointer to nil. Okay? So the problem is, if I destroy this, I still have the window pointer. I'll actually print it out for you. Oops, not that. The G dot window. Okay, let's do this twice. And I'm going to say G dot window equals nil. And then let's print it out again. Okay, so what's this up here? That's supposed to be ERR, not error. Right here, ERR. Okay, so it says we have one problem somewhere. Let's find that. Right here. Oh, okay, that's fine, because I'm not using it yet. So we have this initialize function set up, or we have this error. We're returning the error. There's our return. We're running this window with all the title, the centered X, centered Y, the width, the height, the flags. We're seeing if it's got an error, and we're reformatting that error and then returning it. Otherwise, we're returning which essentially is nil. And then for our to close this down, or to reverse this window, we're destroying the window, and I'm just printing that the pointer is still populated. So it's basically still giving us an address to memory we no longer own. So we cannot use this memory anymore, even though we still have an address to it. And then I'm going to set it to nil and print it out again. So down here, we need to actually use these. So like I did up here where I deferred closing, the initialize, I know there's only one thing in here now for initialize method for game, but there's going to be multiple things in here. So this could fail anywhere along the line. So I'm going to defer this first and then call this. So there's the defer call on that. And then I'm going to do this if error g.init. And then I need to check if there was that is not nil. Okay, so if this is not nil, I'm going to be doing the same thing that I was doing up here, where I am just printing out the message to standard error, and I'm also returning from this function. And if either one of these returns, if this returns right here with an error, this defer is going to be called, and then this defer is going to be called. So since this was the last one added, this is like a queue. It's like last in, first out. So this was added to the queue. This was added on top of the queue. When this goes out of scope, when this returns and goes out of scope, this is coming off the queue and being used, and then this is coming off the queue and being used. So that's going to clean up anything that was happening in it, and this one is going to clean up anything that was happening in initialize. So we're shutting down whatever we've created and allocated memory to, we're shutting it down in a reverse order. Okay, so that should be good. And let's run that now, and we'll see these pointers. I'm just going to run this standard way. Okay, see this first one? Even though we destroyed it, we have freed the memory. We can no longer use that memory. If we were to try to access that memory now, we would get a segmentation fault. So that's called use after free, or it's a dangling pointer. So that's bad. So we're always going to set our pointers to nil when we destroy them or free them. And this is what it looks like when it's been freed, or when it's been set to nil. It's, this is an address, this 0x0, that's address of 0 basically, which is our nil. Okay, so that's up here. That's me printing out the 2. So we will be seeing this basically us creating something and then us destroying it in reverse order and us setting it to nil. It's the same thing for the creating the window, but it's simpler. So here's the window, the render. So we have the window, we've destroyed the window. Now we have create render. And this one just takes the pointer to the window. It takes an index and it takes a flags. Now I can tell you, it's not written down here about it. It just tells you to link to it. But I can tell you this is the pointer to the window that we just created. This is an index to what, index of the render. Okay, so -1, it's what render driver should be used, and it's going to be the first available one is -1, which is what we're going to use. The flags, I use render accelerated. This is the normal SDL documentation, not the Go documentation. So I've used this, but you can just set it to 0. But I'm going to use SDL render accelerated. It'll be SDL underscore. It'll be lowercase SDL dot for right here, for all the Go stuff. So basically, we need 3 things. We need a window pointer. We need -1 for the render, the first available render driver, and then the flags will be the render accelerated. So we're going to do it very similar to this one up here. And this is game, we're initializing the game. So we need to hold on to the render. It's returning a render, by the way, and let's show it. This is returning a render, pointed to a render, and an error. Okay. So we need in the game struct, we need a render. That's the name of our variable. And then the type is an STL render. Okay, so we got that set up. Now down here in the game initialize, the game init method, we are going to create that render. So just like above, because we're returning a pointer to a render and an error. This one is STL create render. And this is taking in the pointer to the window, -1, and then SDL, and this one is render accelerated. Right there, render accelerated. Now we're checking the error. And if there is an error, we're doing exactly what we did above. This one right here. But we're going to call this error creating renderer. Now that we've created a render, the way we destroy a render is the exact same as the window. And I'm going to put it above. It's going to be a last in, first out. So I'm putting it above it. Render.destroy, and then we're going to set that pointer to nil. Okay? So that's the same thing. It's always when I create something, I'm destroying it. And I'm doing it in reverse order. So it's going to be modules happen first, coming online, and that the module being closed is the last thing happening because it's deferred. It's going to happen. It's the first deferral, so it happens last. And then these are coming online one by one, and they're being destroyed one by one in reverse order. I'm just going to make sure that this compiles. Okay. Okay, so so far we have created our window and a renderer, and we're destroying them. So now what we need to do is actually talk about displaying something. So the renderer is it's like a canvas that you paint on, okay? So you have this canvas that you paint on, and the way that old games used to work is you used to paint directly on the canvas that people were looking at while the game was happening. So each cycle of your game loop, you would start drawing the background, you would start drawing the sprites in the front, and the very last thing might be the player sprite gets drawn, and it's on the screen for the least amount of time. And then the screen is cleared, and then the background starts getting drawn on again. So the player kind of flashes or blinks because you're seeing it being drawn, basically. And the thing that's on the screen for the least amount of time kind of flashes and blinks. And that was the way old games used to work a long time ago. And that means there's no buffering happening. It's just showing you the screen that it's drawing on. But SDL is like that uses like a front and a back buffer. So you draw to the renderer, and that's kind of like if a painter was has a painting on display that he's already painted, and it's on display, and everybody gets to see it, and then he's in the back room painting another painting. And nobody sees that. People are just looking at the painting he has done. And then when he's finished the painting, he walks out and he just swaps the two paintings real quick. And then he goes into the back room with the old painting and he clears it and starts painting on again. But everybody just sees the painting that's on display. And they see that switch happens almost instantaneous. So what we have here is we're going to clear our renderer, and then we're going to present our renderer. So we can clear the render and we can draw on it and everything else, and you don't see that. Your game screen doesn't see that. It only sees what was presented. So think about clearing our render. We can clear it, but even if we clear it, nobody sees that we cleared it. It's a back render. It's a back buffer. And we can then draw on it and do everything that we need to do. But then when we're done, we're going to present it. And once that happens, it's going to immediately display. So it's not actually being drawn to what you see. It's being drawn on a render you don't see, and then the pointers are just flipped real quick. And it happens instantaneous for the people watching. So we're going to use a render clear just to clear our render, and then we're going to use a render present to display the render. And then because this is going to happen so quick, and then the program will close without us seeing it, we're actually going to delay the program for closing for 5 seconds with SDL delay to make sure that we get to see this window that's opening. So we have render clear, render present, and these are methods of the render, both of them. And then we have just a function that's delay. So I'm going to show you what it looks like before we do the render thing, and I just delay it. because we can just delay it right now. So I'm going to make one last method for this video. And what it is going to be is we have this initialize, we have this close, but I'm going to make a run. So right down here, right before the, right before the main function, right after this one, we're going to make a last one. This was going to be our run method. This is where our game loop is going to be. So we're initializing and shutting down SDL just as modules, and then we're initializing our game and shutting down anything that we're loading and stuff for our game to load in. We will have media that we load in another method later, but not this one. And then we have our run that's actually going to run the game. So if we just put in here, if we do SDL delay, now SDL delay is, it takes in milliseconds. So if we want it to delay for 5 seconds, we need to put 5,000 in there because it's in milliseconds. So let's put 5,000 in. And what we're going to see is we're going to see a window get created, but it's going to be not right. It's going to show what the screen looks like under the window. We're going to see a border around it. If we try to move it around, it's just not going to look right. It's because we haven't done anything with the renderer yet. So I'm going to run this. Oh, sorry, we didn't call the run method. Now, this run method doesn't have any error associated with it. So we're just calling it directly. We're not going to be checking errors in our game loop. Okay, there's that screen. Now watch if I move it. It's just not right. Okay, so let's clear the renderer. We're going to get a black screen, which is exactly what we want. So above that, we're going to, so that was always being created, by the way, the window. We just couldn't see it because it was opening and closing so fast. If I take this out, right, and we run it, it's just going to happen immediately. We're not going to see anything happen. See nothing happen? That's just because it happens too fast. But what we need to do is we need to clear. So this will be g.render and then clear. Now, if we do this clear, we're still going to see nothing change. We have the 5-second delay in there, so we're going to see our window, but it's going to be still messed up. See? So what we need to do is we need to present it. So we have a render that we cleared, but we haven't presented it yet. Okay, so now we should get a black screen. There we go. And that's what we should be looking at. I know it's a very lot. It's almost, was it 90 lines of code to get us there. And let me show that it has a title. It says open window up here. So if you're in a floating window manager, it'll say it up here. Yeah. So I know it's a very long video. That's a lot of information to cover. It's kind of going from 0 to 60 there. It's 100 lines. This is the longest thing. This is all boilerplate setup. But basically what we're doing is we're importing our packages. We have standard library packages for format, for OS. We also have a third-party package right here, SDL, which is the SDL binding for Go. We have some constants, 800 and 600 for width and height in our title for our window. We have our game struct right here, our declaration of our game struct. And it's got the 2 pointers for window and render. And then we're declaring that struct up here, but we're not doing anything with it first. First, we need our function that is just bringing SDL online. It needs to be brought online, and we're editing the kind of the message, the error message that's coming out of there. So we're just adding on our own bit to the beginning of it. And this is our shutdown right here. This reverses this. So this brings SDL online. This shuts SDL down. So that's happening here. We're deferring the close, and we're bringing it online, and we're seeing if an error occurred so we can exit out or not. Let's go back up. So we have our initializer method, and that is populating our pointer and also checking if there was an error that occurred and giving a nice error message plus the real error. And the same with the render. We're populating our render pointer and creating a message if it erred. And then in reverse, we're destroying that render and we are setting it to nil, and then we're destroying the window and setting that to nil. So that gets called down here. We're deferring the close, and then we are running the initialize and checking if it errors. The close doesn't have an error on it, and neither does this close. So we're not checking errors on those. Those are happening no matter what. And then we're running in our game loop, things that happen in a game loop, I don't test if they failed or not, because they're happening over and over again, 60 times a second or more or less, depending on what your computer's doing. So I'm not checking those, because a lot of times if they fail, it's not important. It's really important if you're loading or starting up SDL or loading an image in. If that fails, that's a really important thing. But if your game loop, if the render didn't clear for one frame for some unknown reason, or something didn't have enough time to draw, it's not catastrophic. Or a sound effect didn't have enough empty channels to play the sound, and it just skipped it that one frame, it's not really important. So the run is going to hold our game loop later on, and so we're not checking if this is going to, if anything's erroring here, we're not checking. We're not interested in that. We just want it to run. I know that's a whole lot of information to get through. So I hope that was entertaining or educational, and that will be it for this one. And that's how to open a SDL window. In the next video, we'll showing how to close it down and actually making a game loop. Okay, so thanks for watching, and bye.